In this short video, I will introduce you to decay equations. Let's begin by reminding ourselves of the three types of radioactive decay. We have alpha particles, beta particles, and gamma radiation. Alpha particles are made up of 2 protons and 2 neutrons, which makes them identical to the nucleus of a helium atom, but note there are no electrons. Because of this, they are very heavy relative to the other types of radiation, and therefore travel quite slowly. They are the most ionizing and the least penetrating. Beta particles are made of one high energy, high speed electron. Note that this electron did not come from the electrons that orbit an atom, rather it has come from the nucleus due to a neutron turning into a proton within the nucleus as part of the beta decay, and that releases an electron from the nucleus. And finally, gamma radiation is not a particle at all, it is a burst of high frequency electromagnetic radiation like visible light or infrared or ultraviolet. We can give mass numbers and proton numbers to our alpha and beta particles. The alpha particle has 2 protons and 2 neutrons, so it has a mass number of 4. It has a charge of 2, so it has a proton number of 2. Beta particle has a mass of 0 because an electron is so much lighter than a proton or a neutron that its mass is considered to be almost 0. And it has a charge of -1, so its proton number here is -1. A typical exam question might tell you that uranium-238, uranium has a proton number of 92, decays by alpha emission. So an alpha particle is produced. And it may ask you to work out which element the uranium decays into. So to work this out, it's relatively straightforward. We must make sure that the mass number on both sides of our arrow is equal, and that the charge number, the proton number, on either side of our arrow is equal. So 238 must equal 4 plus something else. So that something else must be 234. Likewise, we can add up along the bottom. 92 equals 2 plus something. So this value here must be 90. Now in an exam they'd usually give you enough information to work this out for yourself. But we can look up from the periodic table, we'd find that the element with the proton number 90 is thorium, so to complete the decay equation we have TH. So the full decay equation here is that uranium-238 decays by alpha decay to produce thorium-234. The process for beta decay is similar, however it's easier to make a mistake in this one due to the presence of the negative charge beta particle. So let's begin here with carbon-14. Carbon always has a proton number of 6, which will decay this time by beta decay. Remember, the mass of a beta particle is 0 and the charge is -1. So once again we must add up along the top. 14 is equal to 0 plus 14. So whatever isotope we're dealing with here will also have a mass of 14. And along the bottom, 6 equals -1 plus, now be careful here, 7. 7 plus -1 equals 6. So this adds up, and this will give us nitrogen. It may seem illogical that the proton number can increase in an element, but remember this beta particle is formed because a neutron turns into a proton. So it's perfectly consistent that the proton number should increase by 1.